Hello, everybody. We are back with another visual pattern challenge. In these challenges, you look at a visual pattern. It's got steps. So here's step 1, step 2, step 3, step 4, and you try to figure out what's going on. How is it changing? What's the rule here? And then you use that knowledge to predict how many, in this case, triangles are going to be in the next step. So how many triangles in step 5 for us? And then, if you can, how many in step 43, much more difficult, and can you write an equation that would model the number of triangles in any step at all? So that's the challenge. If you choose to accept it, pause the video, work it out, and see how you do. All right, well, let's just see if we can look at this pattern first and understand what's going on. We're starting with a single triangle, and then we add this line of 3 underneath it, I think. At least that's the way I'm thinking about this. So adding a line of 3 underneath it. And then we've got that line, that one triangle, the line of 3, and then we add a line of 5. So it looks like the line is getting longer. And I guess it's getting longer by 2. So you're taking maybe the previous step number plus 2 and then adding that. That seems complicated. Let's see if that pattern bears out here. So 1, 3, there's 5, this is increased by 2, this is 7. So I would guess in the next one we would have 9 triangles added to the bottom. So that would be step 5 right there, however many triangles that is. Let's see, 1, 4, 9, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So it looks like in step 5, we'd have 25 triangles. It's a more complicated pattern than we've seen before. And I think when you see a pattern that confuses you or is difficult at all, or even if it's not so difficult, but you want to verify that you're doing the work correctly, it's good to make a chart. So I'm going to make a chart with the step number and the number of triangles. So in step 1, we have 1 triangle. In step 2, we have 4 triangles. In step 3, we have 9. In step 4, we have 16. And in step 5, we're predicting 25. So I'm going to put that there. Now, you may already see a pattern here, but this is different from what we looked at before. Usually, the next step in looking at a pattern is to determine if it's a linear pattern by taking the difference. So how much does it go up each turn? This one goes up by 3. 4 minus 1 is 3. And then 9 minus 4 is 5. And 16 minus 9 is 7. And 25 minus 16 is 9. Okay, well, I guess that makes sense, right? Because the row on the bottom gets bigger by 2. So first we had 3, then we had 5, then we had 7, then we had 9. But this is not a linear pattern, which we've seen many examples of before. When the difference is not a constant number, the same number each step, it's not a linear pattern. So what kind of pattern is this? We can't use that formula, that equation for a line to model this. Well, a good thing to do next is actually to take the second layer of differences, take the difference of the differences. So 5 minus 3 is 2, 7 minus 5 is 2, and 9 minus 7 is 2. Aha! So now we get a constant here of 2. What this means, actually, when the difference of the differences is a constant, it means you're talking about a quadratic formula. So x squared is going to be in this somewhere. And maybe you had seen this immediately. Maybe you noticed that 1, 4, 9, 16, 25 were all perfect squares. And if you did, good for you. But if you see this pattern, if maybe these numbers, if they weren't like obviously perfect squares, if something else was going on, you'd want to take the difference and then take the difference of the differences. And if you got a constant number here, you know it's going to be a quadratic and there's going to be an x squared in it somewhere. So that's the place to start with your formula, with just y equals x squared. And in this case, we don't have to go any further, right? Because if y is the number of triangles and x is the step number, I mean, we can just try it. So y equals x squared. Well, 1 squared is 1. Y equals 2 squared, that's 4. Y equals 3 squared, that's 9. So it is working out. 4 squared, 16, 5 squared, 25. So that is our formula. Kind of the most basic quadratic formula you can have. So let's write that y equals x squared as our equation. So there's only one more step to do here, and that is to figure out how many are in step 43. So what we're going to do is just plug step number 43 into this equation. So y equals 43 squared. And this is going to be a pretty big number. I just punched it in on my calculator, and it's 1,849 triangles. So that's going to be a lot of triangles. Well, how did you do on that one? I think this was a much more difficult one. It's the first nonlinear pattern that we've seen so far. Did you get it? Did you get the step 5 number at least? Let me know. Thanks, everybody.